Hello, and today we are going to talk about quasi-experiments. So we've gone over correlation and we've gone over true regular experiments, but quasi-experiments are kind of somewhat in between. So to get it started, let's kind of go over briefly the other research designs that we cover in this course. So we have correlational studies or non-experimental design, however you want to say it, that means the same thing. But this is an examination of possible relationships between variables. There's no manipulation, so there's no independent variable. There's also no random assignment. Essentially, I can give, all my students a questionnaire on depression and a questionnaire on stress, and I can use a correlational design to find the relationship between stress and depression. But I'm not manipulating that, and I'm not randomly assigning you to groups. You guys are all taking it, both quizzes or both surveys, and you guys are just in the classes that you're in. There's no random assignment there. With experimental studies, we have a little bit, it's obviously very different from correlation, where we do manipulate independent variables. So maybe half of you are going to get a study guide for the exam and the other half don't. I wouldn't do this, but I want to examine the relationship of how having a study guide impacts your exam scores that's coming up. So I have, half of you are randomly assigned to receive a study guide, the other half are randomly assigned to not receive a study guide. And that would be a between subjects design where, you either have the study guide or you don't flip-flop back and forth. But when it comes to within subjects design, instead of random assignment to the condition that you're in, be it the study guide or no study guide, instead it's the order in which you take it. So maybe you're going to take an exam in a hot or a cold classroom, with a within subjects design. In terms of the random assignment that's there, it's not random assignment, it's counterbalancing, which you're randomly assigned to the order in which you'll take the test. So some will take it in the hot room first, then the cold, and other people will take it in the cold room first and then the hot. So that's that difference for within and between subjects design. Now with experiment or quasi-experimental studies, we still look at the possible relationship between variables. There is a manipulation of an independent variable, but there's no random assignment. And we'll get into more details on that later. Obviously, this is the quasi-experimental lecture, so obviously we're going to get more into detail. Anyway. So with quasi-experiments, it does have some benefits of experimental research. We do not have the issue of the directionality problem like we do with correlation, because we have an independent variable that we are manipulating. So with that independent variable manipulation, we can say, oh, it's because we manipulated this that's causing this to happen. Now with correlation, we didn't have that manipulation, so we can't cause a direction of this causes this or that causes that, because we didn't manipulate anything. Who's to say it's not the other way around? But it does have some cons of correlational research, where it doesn't really account for confounding variables, since we don't have random assignment to the groups, which is part of how we control for confounding variables. Well, it doesn't do that. So clearly we can't really control for those as well in a research design that's not able to do that. And with no random assignment, we also have low internal validity, which, keep in mind, that is when the groups, everything is equal across the experiment except for the manipulation. Well, we'll get into some details of quasi-experiments and we'll see how it has low internal validity. So quasi-experiments are used in situations where randomization is hard or pretty much impossible. So if we're going to be looking at gender differences, then we can't really randomly assign people to be to classify themselves as a man, as a woman, as a transgendered male, as a transgendered female, as whoever. We don't really have that power as researchers because we're not God. So we don't really have that. Same thing if we're looking at age differences. It's not random. We're not randomly assigning our participants to be, okay, you're going to be in our 45 to 50-year-old group. You're going to be in our 15 to 20-year-old group. It's pretty much, we take it as we come. Like whatever the participants are, oh, we have a 42 or a 47-year-old person. Well, they're going to be in our 45 to 50 group. There was no random assignment there. It just, they are what they are. And location differences, if we're going to be looking at the differences between, let's say, Californian citizens and people who live in Nevada or Oregon or just anywhere else, if we're going to be looking at differences between people who live in California and people who live in Nevada, we're not manipulating that either. We're not randomly assigning people to live in California or randomly assigning people to live in Nevada. Those groups are kind of already preset. You either live there or you don't, but we didn't have any say as to where you lived. So true experiments where we have the random assignment, manipulation of the independent variable, they use an equivalent groups design, and they do this through using random assignment. So, you know, you have every participant has an equal probability of being in one of our experimental conditions or the other. There is no, well, you live in California, so I guess you're there. It's like, oh, okay, so you're going to take an exam in a hot or a cold classroom. Let me randomly assign you to which one you're going to take one in. It's just you have that control in a true experiment. So we have these equivalent groups. When you use random assignment, you're way more likely to control for possible confounding variables, and with so these groups are going to be more equivalent. It's just random selection of people. So some might be really good at the test, others might not be, but you want both groups to be a combination of the two. You don't want one group to have all of the scholars and the other group to have people who maybe don't know how to read. You want an equal group, you want an equal distribution in each of your groups that you're experimenting with. So by having these groups as similar as possible, that's letting the researcher be able to be more comfortable in saying, oh, the biggest difference between the scores of this group and that group is our manipulation of the independent variable. It's taking the exam in the hot room or the cold room or what have you. So true experiments, again, the ones where we do have random assignment to groups or counterbalancing random assignment with within subjects design, that is using the equivalent groups design. Quasi-experimental uses a non-equivalent groups design. So this is where the groups are not randomly assigned. So for my thesis that I wrote to get my master's degree, I was looking in the differences between online and face-to-face students who were taking stats or Psych 42. So I did not randomly assign those groups. I could not. It was pretty much, okay, I'm ready to collect data. Okay, I'm going to send the surveys out to people who are in online stats classes and people who are in regular face-to-face classes. I know this sounds really dated considering that there are no face-to-face classes now, but bear with me. Back then, when times were simpler, there were a combination of online and face-to-face classes. But I did not randomly assign my students or my participants to be either in online or face-to-face. They registered for classes before I started collecting data. They, you know, and they were in those classes for whatever reason. Maybe some people didn't like online learning, sorry. Maybe some people, you know, for people who chose face-to-face, they picked one that worked with their schedule. Maybe they work, and so they wanted to work around that. People had different reasons for choosing face-to-face or online classes. I didn't make that choice. They made it for themselves. I just pretty much, once they made their decision months prior, because that's when they registered, and then I collected data months later, I just kind of worked with, all right, who are the people who are taking online classes? Who are the people that are taking face-to-face classes? Boom, done, bam. So these groups were not randomly assigned by me. I wasn't sitting next to all 222 of my participants when they were registering and saying, okay, Jimbo, I'm going to flip a coin. I know you're torn between taking the face-to-face class at either Monday, Wednesday at 10 or Tuesday, Thursday at 4. But guess what? Nope. I flipped a coin. You're taking it online, dude. So I've randomly assigned you to that group. I didn't do that. It was just the groups that were already there. But with that, it's non-equivalent groups design. Whenever the groups are predetermined for you, be it they're taking online or face-to-face classes, or they classify themselves as male or female or transgender female, transgender male, or, you know, race, ethnicity, that's another group that's kind of predetermined. We can't randomly assign people to be African American or Latinx or, you know, white. We can't do that. It's just pretty much what you got, you know, what are you? And then that's where you're going to be. We can't randomly assign you to be old or randomly assign you to be young. You either are or you're not. So some examples of quasi-experimental design would be a pre-test and post-test design, or a before and after. So this is where participants are measured on the dependent variable before and after the treatment. So let's say that I give my students an exam on common cephalopoda, which are basically octopi. I love octopi. They're my favorite animal. So of course I'm going to go with that. So I give you guys an exam on octopi and what you know about them. And then you know, turn in your exams to me and I score them. And then I give a lecture on octopi and, you know, all about them and how awesome they are. And then I test you guys again using that same test, and I compare your scores on how you scored on the octopus exam before and after me actually teaching you about them. So this is similar to within subjects design because it's the same students that are taking it, but counterbalancing is not possible for this, because consider both the conditions. The conditions are before you learned about octopus and after you learned about octopus. So I can't randomly assign you to be, oh, well, you're first going to take the exam knowing about octopi, okay? And then you're going to take the exam not knowing about octopi. It doesn't work like that. So it doesn't work backwards. So pre and post test design, while they do while they do use a within subjects design, counterbalancing is not possible, because once you learn the material, you can't unlearn it. So it has to go from a before and after test, or pre-test, post-test. It has to follow that. So, yeah. So one thing that happens with pre-test and post-test is that, oh, if the post-test score is higher, we could say, oh, hey, my lecture on octopi really helped. You're doing better. You perform better on the second time because of my score, or because of my lecture. That could be the case, but we can't necessarily always be certain. There are three different things that can contribute to changes with these types of things. First, we have regression to the mean, where extreme scores tend to level off over time, where maybe the first time you took the exam, you scored super poorly because you didn't really get much sleep that day. You were like falling asleep as you were taking the exam, or you just had a rough day. Maybe you're having some personal problems with relationships at home, or you just got a lot of stuff going on, and so you're not really focused, and so you score really poorly the first time you take it. The second time you take it, you know, you're feeling a little better. You're feeling like, oh, you know, I was having a rough day, and here I am being lectured to about octopi, and you know what, they're really cool. And suddenly your score gets a lot higher. Well, I could say, oh, it's the lecture that worked, but it could be the first time you took it, you were not in a good headspace. So you regressed back to your mean of that extreme score you got the first time around of being super low, tends to level off over time. Fun fact, if you guys have ever heard, this is kind of off topic, but I always like to bring it up. If you guys have ever heard about the Madden curse, where football players who are placed on the cover of the Madden NFL games, that's like, oh, it's a curse. You don't want to be put on the cover, because then the next season you're going to suck. You know, you're going to have a really bad season. You're going to, you know, get injured. Something's going to happen. You don't want to be on the cover of Madden because you're going to, you know, something's going to happen. You're going to suck. Well, the reason that happens is because regression of the mean. It's not I mean, you can still be superstitious about it. That's fine. But the reason why that it seems like anytime people are on the cover of Madden, their following season, they don't do nearly as well, is because of regression to the mean. Chances are, if you're being placed on the cover of a game about a sport that you play, if you're on the cover of it, you probably had a super awesome season. You probably threw tons of touchdowns, you got lots of rushing yards, I don't know, got a bunch of sacks. I don't know what you did. Depends on who was on the cover and what their position was. But ultimately, you had a really stellar season. And so they say, oh, you're on the cover now. The following season, you probably won't do as well, not because you're on the cover, but because of the regression to the mean. You can't consistently have these like super high, amazing seasons if that's just not the player you are. Sometimes you just kind of get lucky and you just throw a record-breaking touchdown pass. I hate Tom Brady. Anyway, so spontaneous recovery is another, back on topic now. So spontaneous recovery is another reason why we can't just say that it's the treatment of, giving you guys a lecture on cephalopods or, whatever it is that we're doing with our pre and post test. Spontaneous recovery is where physical and psychological conditions improve over time. Just like I was saying, if you're in a really rough go of it, that first time you took the exam, you're like, oh God, maybe you're going through stuff at home, what have you. Well, your condition will improve over time. Days will get better. And so you will score better because you're not in that negative headspace anymore. Or if we were going to look at depression, maybe pre and post test with, first we're going to measure depression, then we're going to give you this depression treatment, and then come back in 2 weeks, and then we're going to measure your depression levels again and see how well you do. Well, sometimes it could be because of this depression treatment. Maybe we have you do some sort of therapy, or we give you some sort of, SSRI, some serotonin reuptake inhibitor to get you guys kind of like, a treatment for depression. It could have been that. That could have been the treatment that caused a change. But it could also just be, well, maybe when we have depressive episodes, they don't tend, maybe yours was on the cusp of ending. And so when you did it, the before test, the pre-test, you were in the thick of it. You were in the worst of your depressive episode. And then 2 weeks later, when you came back to measure your depression, by that point, you were kind of better, so was it the pill that helped, or was it the therapy or whatever treatment that we gave you? Was that the thing that helped? Or was it just that the fact that psychological conditions tend to improve over time, to where when you have that depressive episode, yes, you have them, but then it kind of started to fade. That could have been it. And then natural history, people will just change over time. That's true with everyone. I'm sure if you think about the person you were 5-10 years ago, it's very different from the person you are now. So people just tend to change over time, and that could also have an impact on how you score on whatever it is that the researchers are measuring. So pre and post tests, since they are quasi-experimental, since you can't really manipulate you having the post test and then taking the pre-test, because that's not how time works, that kind of explains how, okay, so is it really our variable that we manipulated, that I gave you this depression treatment and we're going to see how you do, or is it other factors like you're just naturally feeling better? I don't know. So that's an issue with quasi-experimental design. Another example of a quasi-experimental design is an interrupted time series, where this again is a variation of pre and post test design, but it has multiple points of measurement, and treatment is kind of put at some point in this multiple points of measurement. So if I were to give you guys 10 quizzes, which I do, but if I were to give you guys 10 quizzes and based on topics, and I give them on a weekly basis. Now, I don't always give them on a weekly basis. So sometimes we don't have a quiz, sometimes we do, it just depends. Make sure you check Canvas. But anyway, let's say I have 10 consecutive weeks, and each week there's a new quiz based on new things that we've learned. Okay, so I give you guys these quizzes, you take them individually, normally on your own time, whatever. But towards the middle, halfway through, maybe after quiz 5 out of 10, instead of having you guys take these quizzes by yourselves, I instead say, okay, it's a group quiz where you will take your quizzes in groups. So you can set it up on Zoom or whatever you want to do, but you guys are going to be doing cooperative learning instead, and you are going to do activities. I'm sorry, I said you take your quizzes in groups, but cooperative learning where you're, instead of working by yourself, you're working with other people and learning from that. And then I want to see how your quiz scores change. So the quizzes stay the same, you're still taking them individually, but I insert a treatment of, okay, some, halfway through, you guys have your quiz scores, you're taking them individually. Then halfway through the semester, we start doing some group activities that really help to focus on stuff that we're learning in lecture, and then you take quiz scores. So then I want to see how would the inclusion of cooperative learning activities actually change your quiz scores. So this is what this could look like. So quiz 1, 2, 3, and 4, oh, okay, they're all like, yeah, 6, 6, 5, 6, da da da. And then we have halfway through, I only have 8 here because it wouldn't really fit with 10, so just bear with me. But halfway through at quiz 5 here, I start incorporating more learning activities where you guys work together in groups to learn the stuff that we do in lecture. And then those same quizzes that you've been taking throughout the course of the semester, suddenly your grades improve. That treatment can be seen right here. Obviously, this is where the treatment started because we have such a huge jump between 6, 6, 5, 6 to suddenly boom, 9, 8, 10, a lot better scores. Another final example of quasi-experimental research design is the combination design. And this is this combines different elements of different quasi-experimental designs. So we can have a pre and post test, or the interrupted time design, like I just mentioned, where one group has a treatment inserted at some point and the other group just goes without. So if I were to kind of bring this all together, if I had 2 sections of 144, which I do, let's say that for your section, we have the same setup where you get quizzes over 10 weeks or 8 weeks according to this, but you get quizzes over a period of time. And then for your class, halfway through, we start doing the cooperative learning. And then that helps you understand the material better, hopefully. And you're still taking those quizzes. But the other section of 144, so the other class, they do not receive that treatment halfway through. They don't get at week 4 or 5, they don't receive this new collaborative learning techniques where you guys work together to understand the material better. The other class doesn't get that. So your class has, quizzes halfway through, we're going to start doing learning activities, and then we'll see how your quizzes improve. And then the other section just straight up takes the quizzes with no additional activities involved. It would look something like this. So we have class 1 in the yellow baby butt color. I don't really know how to describe it. Anyway, so you have class 1, which received the treatment. That's like, oh, okay, so 6, 6, 5, 6, boom. Suddenly, at this point, all right, congratulations for finishing quiz 4. Now, the following week, we're going to start doing these collaborative learning activities. Boom, suddenly 9, 9, 8, 10. But again, that's not for both classes. That was only for one. So for the other class, here's the same. They're just taking quizzes as they normally do, 5, 7, 6, 6, 7, 7, 6. Their quiz scores kind of remain on a constant. However, with the treatment of what class 1 received with that cooperative learning, boom, there's increase. So keep in mind that with quasi-experimental design, you do not have any control over the groups that you have. So for example, for my classes, I didn't pick who's in my classes. I didn't randomly assign you guys to take the section of 144. You just did. You signed up for it. You're here. Hello. Same thing with my example for online and face-to-face learning. Exact same concept. If I were to do another example, is if I were to do an anti-drug program in elementary schools or middle schools, that's probably a little more pertinent there. And let's pretend that this is face-to-face because I don't feel like dealing with online shit right now. But let's say that I take 2 middle schools in Fresno, California. Let's say Tioga and, Cooper. Everyone thought I went to Cooper when I was a kid because it's my last name. But anyway, let's say that we take 2 middle schools of Tioga and Cooper. And one of the schools, let's say Tioga, we give an anti-drug seminar where over the course of a week, they learn stuff about how bad drugs are and it's super cool not to do them and ew, you're a loser if you do drugs. And let's say the other school, Cooper, does not receive this intervention. They do not receive this anti-drug program that's supposed to be only Tioga does. Well, we have our treatment of drug program, yes or no. You either are in it or not. But then we have our 2 groups, which are students that are attending Tioga and students that are attending Cooper. Now, did I have any control over where these students go? No, I didn't flip a coin between however many students are in total attending Tioga and Cooper combined. I didn't take each individual 7th or 8th grader and say, okay, you're going to go to Cooper, you're going to go to Tioga. You know, I didn't flip a coin or do random number assignment or anything like that. They just go there because they live in the area or what have you. They're in that school zone. So with that, if we were to look at the difference, like, oh wow, you know, Tioga students, they're really like anti-drug. They're really like, ew, say no to drugs. Well, this is where, okay, cool, it could be the program, but this is where different things tend to kind of come in. Maybe someone at Tioga, maybe someone in the neighborhood or someone, you know, at school, maybe their parents had an issue with drugs and it was a really big thing where one, like Jimbo's parents passed away because of a drug overdose, although that's not really something that you'd want to share. But anyway, that's kind of like personal business. Let the kid grieve in peace, for Christ's sakes. But anyway, it could be that one school has things happening at it that the other school doesn't. Maybe someone at, like I said, at Tioga, maybe one of their parents passed away because there were some drug complications. Well, that could have an impact on how the kids view drugs at that point. They could say, ooh, you know, all this like this anti-drug program, it's really like cookie cutter and like, ugh, but it really hits home when my friend's dad actually passed away from drugs. Like this hits a lot differently. So that could be a reason why their scores are different or why their views on drugs are different. And it had nothing to do with that anti-drug program. It was more real life shit. But that student didn't also attend Cooper. He only attended Tioga. So we don't really have that equivalent thing happening. Different things are happening at Tioga than they are at Cooper. So this is part of quasi-experimental design and part of how, okay, yeah, we can manipulate, like, yes, I am choosing Tioga to have the anti-drug program, or I'm choosing Cooper. Maybe we go with Cooper to have the anti-drug program. We choose where we are placing the treatment. So we still are manipulating that independent variable. However, in terms of the groups that we have, they are not equivalent at all. We have a totally separate student body that was not randomly assigned there. We just kind of gotta, like we said, we just gotta kind of roll with it. So with that, quasi-experiments can be useful because we can't manipulate kids to go to one school or the other. It's, this school is down the street from this kid's house. I'm not gonna make him go across town because I'm a scientist. It just, that's how it is. So when you don't have random assignment where it's not possible, we have to use quasi-experiments. That's just the name of the game. But there's always going to be those issues where it's like, okay, well, since these groups aren't randomly assigned, they're not technically equivalent or not as equivalent as they could be if we did assign them randomly. So, you know, we're going to have confounding variables of, oh, one school has a kid that passed or has a kid's parent that passed away, and that's impacting their drug feelings. Versus the other school, that didn't happen. So that's a confounding variable of Tioga students might be more anti-drugs or a little like, ooh, I don't know about that. That's scary. That's dangerous. As opposed to Cooper students who were like, nah, whatever. Or I don't know, insert any other middle school there. Doesn't really have to be Cooper. But that's my point about quasi-experiments. It's hard to tell if it is it exactly the manipulation or is it just other factors. And since these groups are not equivalent, since they're not since there's low internal validity where the environment at Tioga is much different than the environment at Cooper, it's kind of hard to determine that hard causation there. But that is quasi-experiments. As per usual, if you have any questions, feel free to email me, message me on Canvas, or hit me up during my office hours. It's ready and open for you. So with that being said, that's my lecture on quasi-experiments. So I hope you guys have a good day and like and subscribe.